So we've been practicing writing equations of lines, whether we're given a graph, whether we're given 2 points, whether we're given information about slope itself and a y-intercept. And remember, the two main equations we've been writing are those in slope-intercept form, which is y equals mx plus b, where m is your slope, your rate of change, and b is the y-intercept coordinate. And the other option was our point slope form, y minus y1 equals m times the quantity x minus x1, where m again is your slope, and x1 and y1 are just the coordinates for any point given to you on the line. Remember, the standard form is subtraction, so if you see the subtraction, these coordinates here are positive. If you saw an addition, remember that came from subtracting a negative, so the coordinate would be a negative. So let's practice writing equations of your linear functions based on what we're given. So in the first problem here, it says write the equation of a line that contains a slope of 5 and a point of 0, 12. Well, we know the slope, that's m, and the point is 0, 12. Hopefully you recognize the point 0, 12 is a y-intercept. This would be perfect for writing an equation in slope-intercept format. Y equals mx plus b. So here we would have y equals 5x plus 12. If you didn't recognize that point 0, 12 as the y-intercept and decided to write it into point slope format, that's okay. Substitute the coordinate values in for x and y and 5 in for m, and then simplify. X minus 0 is just x, so we would have y minus 12 equals 5x, which you can see is if we just added 12 to the other side, you're back to your slope-intercept form. But this would be what it looks like in your point-slope format versus slope-intercept. You really should recognize when you have an input of 0 and the output of a number, that's your y-intercept, and slope-intercept form would be your best bet. Here's another scenario. If you have this graph, could you write an equation to represent the line? Notice on this line we have 2 points highlighted, negative 3, 5, and 2, 0. 2, 0 represents the x-intercept on your line. And as long as we have these 2 points, we could work on finding the slope between them. So graphically, we can see we're going down 5 units and over 5 units to get from those 2 points. Well, negative 5 divided by 5, that's a slope of negative 1. Now, because we have a point and we have a slope, this would be perfect for point slope format. And you could use either point to make that happen. So again, remember your point slope format, we're going to take our x coordinate and substitute for x, y substitute in y, and our slope substitute for m. And it doesn't matter which point you choose, just make sure as you're substituting the coordinates in for the values of x and y, that if there is any simplifying that needs to occur, you make sure you're doing that. So the point on the left, negative 3, 5, would come here. And as I'm looking, I see subtracting a negative, which means I have a positive. So I really want to write that as y minus 5 is equal to negative 1 times the quantity of x plus 3. If I use the point on the right, 2, 0, remember y minus 0, that's just y, equals negative 1 times x minus 2. If you notice, what we could do here in this point slope format is distribute the negative 1 to each term. That would put it into slope-intercept form, which is y equals negative x plus 2. Perhaps you noticed in the beginning, back at your graph, you saw the y-intercept here. So maybe you just went directly and wrote y equals negative x plus 2, and that's fine. If you were unsure, you do have the other 2 points given to you, where you could write an equivalent format as well. So again, you could write y minus 5 equals negative 1 times the quantity x plus 3, or y equals negative 1 times the quantity of x minus 2, or y equals negative x plus 2. All of them are correct equations for the same line. Let's look at another scenario. Can you write the equation of the line that contains the points 6, negative 2, and 0, 7? If we're given 2 points, we can find the slope between the two. And perhaps you notice that you have the point 0, 7, which also represents a y-intercept. So first thing we could do is work on finding the slope, the change in y over the change of x. If we do 7 minus negative 2, that's 9, because again, subtracting a negative is taking the opposite, it's positive. And then 0 minus 6 is negative 6. 9 and 6 both have a greatest common factor of 3 we can divide out. Therefore, our slope is negative 3/2. So if I have my slope and I have my y-intercept, I could write my equation in slope-intercept form. And that would be y equals negative 3/2 x plus 7. Now, if we wanted to use the slope and a point, perhaps 6, negative 2, we could write it into point-slope format as well. So again, our slope m would be negative 3/2, and we're going to substitute 6 in place of x sub 1 and negative 2 in place of y sub 1. And then we want to look to see, is there any simplifying that needs to occur? Yes, y minus a negative 2, that should be a positive 2. So we should have y plus 2 is equal to negative 3/2 times the quantity x minus 6. Now, again, if you forgot that 0, 7 is a y-intercept, you could have done the same thing with the point to write it into point-slope format. And notice you would have to simplify the x minus 0 just to be x. And again, at that point, it'd be very easy to put it into slope-intercept form. So again, you have 3 possibilities for your equation. Y equals negative 3/2 x plus 7. Then we had y minus 7 equals negative 3/2 x. Or y plus 2 is equal to negative 3/2 times the quantity x minus 6. All of those are still referring to the same line. What if we had a table of values? The table shows the growth of a corn stalk. Can you write the equation of the line? So we have to think about, what are we measuring here? The inputs are days and the outputs are heights in centimeters. Well, to find the slope, we just need 2 points to do that. And we know that it's a line, so it does not matter which 2 points we use. If they did not tell us a line, we'd want to check every interval to see if it had a constant rate of change. But since it's a line, we only need to pick 2 points. So I'm going to pick these 2 points for day 2 and day 3. So remember, we want to do the change in y over the change in x. So as we do that, the change in y over the change of x, 2.89 minus 2.10, that's 0.78. 3 minus 2, that's 1. That simplifies to a slope of 0.78. Now, as I look at my table, I don't see a day 0, which would be my y-intercept. So this would be best written as a point-slope equation. So I just need to pick a point then to use to write the equation. So I could use any of them on here. I'm going to go with 1210. And so to set up that equation, we're just going to substitute the x value in for x sub 1 and the y value into y sub 1, and we have our slope m as 0.79. So my equation could be y minus 10 is equal to 0.79 times the quantity of x minus 12. Again, it could be any point from your table to write the equation in point-slope format. The y value would be substituted here. The x value would be substituted here. They would remain subtractions because none of these values are negatives, and it would still be the equation for your line. And again, well, what is this telling us? The slope of 0.79, that's the change of the height in centimeters for every 1 day that goes by. So the meaning of this is every day the corn stalk grew 0.79 centimeters. Let's take a look at another scenario. The graph below shows the amount of money earned at a bake sale on a particular day. The first customer came 20 minutes after the bake sale started. Can you write an equation to model the money earned over time? And so here's our graph. So can we write an equation talking about the money earned over time? Yes, we can. On this graph, we can see that we have some very distinct points given to us. And we know that any 2 points we can use to find the slope, the rate of change for the scenario. And as I look at my graph, I do not have a y-intercept, so slope-intercept form would not be best. We should probably write this into point-slope format. So we're just going to pick 2 points to find the change in y over the change of x, the slope, the rise over run. And then I can use a point to write the equation of the line. So let's say I use these 2 points here, and visually I can see that I have a change in y, a rise of 300, over a change of x, the run of 50. So the change in y over the change of x, 300 compared to 50, that simplifies to a slope of 6. Then I just need a point to write my equation in point-slope format. So what if I use this point here, 70, 300? I can substitute that in to my point-slope format, which is here. So I now have y minus 300 is equal to 6 times the quantity x minus 70. Now, that's not the only point that we could have used to write the equation. I could have also used this point here, 120, 600, to write the equation. So if I use that point, my equation could be y minus 600 is equal to 6 times the quantity x minus 120. But I didn't have to just use that equation, or sorry, that point to write the equation. I also could have used this point here at 20, 0 to write the equation, which would be y minus 0, which is just y. So y equals 6 times the quantity x minus 20. And those are 3 points that we knew the coordinates of. Well, what does the slope mean of 6? Well, every minute that went by, the bake sale earned $6. Now, we said the graph did not show a y-intercept, and that's why we chose to go the point-slope route. Now, if you notice with this last one, using the x-intercept, we could write the equation in slope-intercept form by distributing the 6 to our quantity. That means the equation in slope-intercept form would be y equals 6x minus 120. It's still talking about the same line, and we know that it's not showing up on our graph because they were talking about the negative money earned, but also they were tracking the time that people were coming to the bake sale. So no one came to the bake sale at 20 minutes, therefore that's why that part of the graph was not showing. And so we don't have to put it into slope-intercept form, but if you did, that would be your correct equation. All right, let's take a look at another scenario. Could you write the equation of the line based on these givens? A cell phone costs $99.99, and then you pay $29.99 for each month of service. What would that equation look like? Well, what do we know about the problem? The cell phone costs itself $99.99, so that would represent your y-intercept, your starting point. Then you pay $29.99 for each month. That would be your rate of change, so that is your slope. So if we were going to write this, we could write it into slope-intercept form fairly easily. Y equals mx plus b, where x is the number of months and y is the total cost. So our equation would be y equals 29.99x plus 99.99. And how about this one? On Monday, John went for a 5-mile run, and it took him 35 minutes. On Tuesday, he went for a 7-mile run, and it took him 49 minutes. Could you write an equation that models John's time and distance as he runs? So again, let's think about what we know. We know John went for a 5-mile run, and it took him 35 minutes. On Thursday, he went for a 7-mile run, and that took him 49 minutes. So it looks like we're comparing the miles being run versus the time. So we could organize this in a table of values. And since we're just given kind of time and distance, we think about that as points on a graph. And so again, that would be a good way to write our equation into point-slope format. Because as we look in our table, we can't see any times of 0, so we wouldn't have a y-intercept to work with. So what is the change for each of these? Well, if we do the change for the outputs compared to the inputs, the change in the distance compared to the change in the time. So if we made our distance our outputs, right? We're going to do 7 minus 5, which is 2, and our time is the inputs. 49 minus 35, which is 14, we've got a slope of 1/7. So again, what does that mean? Well, the output is a distance. So 1 mile takes 7 minutes for him to run. Now that I have the slope, I could pick one of my points and substitute them into my point slope format. So if I wanted to use the first one, I could have y minus 5 is equal to 1/7 times the quantity x minus 35. Or if I'd like to use the second set of data, I could have an equation of y minus 7 is equal to 1/7 times the quantity x minus 49. Both of those equations are talking about the same line based on the given distance and time. So now it's going to be your turn to practice based on given the information for each scenario, whether it's kind of 2 points given to you, whether it's in a scenario written out, whether it's organized in a table, whether it's organized in a graph, or whether they give you some more information, such as giving you just 2 distinct points or telling you, hey, the slope is this, the y-intercept is this. Can you write the equation? And again, we want to try to determine what would be the best method or format, I should say, to put that in. Should it be something in slope-intercept form where you know the rate of change and the y-intercept, or point-slope format because they give you, or you can find the rate of change and you have a reference point on your graph, table, or just a written scenario. So again, your turn to practice, and we're going to monitor your progress.